The topic of this video is finding the domain of a composite function. Let's look at a problem. Given g of x equals the principal square root of the difference x minus 4, find g composed with g of x and its domain. Okay, this is one of those problems where we're asked to find two things, g composed with g of x and its domain. So we're going to have two answers because there's really two questions. Also, we need to remember that in the middle of the process of finding g composed with g of x, once all the function names are gone, we will stop and determine the domain, and then once we have done so, we will return to simplifying if possible. All right, let's begin. First, let's write this. Using the definition, we have g of x, and then close our parentheses. Our innermost parentheses contains a variable, so we work from the outside in, which means we start with function g, and specifically the right-hand side. But everywhere we see an x, we're going to put g of x instead. So this is going to give us the square root of g of x subtract 4. Okay, now we substitute. Wherever we see g of x, we're going to put this radical. So we get the square root of x subtract 4 subtract 4. You have to be very careful when you write this. Make sure that this inside square root stops right after this 4, and make sure that this outside square root goes over the whole thing. And yes, it is okay to have a square root inside another square root. All right, so this is the moment in our problem solution where the names are gone. We had g and g, then we had just g, and now we have no names anymore. So this is the moment where we are going to stop and determine our domain by using the 4 steps that were taught earlier in the semester in a previous video. All right, so step 1 is to start with all real numbers. Step 2, any even radical, then its radicand has to be greater than or equal to 0. And in this particular problem, it just so happens that we have 2 even radicals, and each one has a radicand. So this first radical right here, which I'm coloring in green, has the radicand x minus 4. So therefore, x minus 4 has to be greater than or equal to 0. However, there is a second radical right here, and everything that's underneath that is also a radicand, and therefore must be greater than or equal to 0. So we get the second statement, the square root of x subtract 4 has to be greater than or equal to 0. The green circle must be greater than or equal to 0. Equal to. The thing circled in green must be greater than or equal to 0, and the thing circled in orange must be greater than or equal to 0. Both of these must be true at the same time. And for that reason, we put the mathematical word and in between these two mathematical statements. Okay, great. Let's go ahead and solve both of these. Adding 4 on both sides, this gives me x is greater than or equal to 4. And with this one, I'm also going to add 4 on both sides, but then I get the statement, the square root of x subtract 4 is greater than or equal to 4. And this leaves me with an interesting decision to make. What do I do to get x by itself? Well, it's currently underneath a square root, and one way to get rid of a square root is through squaring. But we have to be careful. When you square both sides of an inequality, you have to verify that both the left side and the right side are positive values. So, is 4 a positive number? Yes. Is the principal square root of the difference x minus 4 a positive? Yes, it's built into the name. The official name for this symbol is the principal square root. P for principal, P for positive. This means it only produces values that are 0 or bigger. And therefore, the square root of x minus 4 will indeed be a positive value. Okay, so with that in mind, we can now square both sides. And when we do, we can keep our inequality symbol unchanged. So now we have x subtract 4 is greater than or equal to 16, and by adding 4 to both sides, we get x is greater than or equal to 20. So at the end of step 2, this is what we have for our domain. X has to be greater than or equal to 4, and it has to be greater than or equal to 20 at the same time. Now, even though we're not done with step 2 yet, I want to just for a moment look slightly ahead at steps 3 and 4. Step 3 is log arguments. There are no logs here. Step 4 is denominators. There are no denominators here. So this is our final answer, but we have to find a way to get these two inequalities together into one statement. This is called a compound inequality. And if you remember your intermediate algebra skills, one way to solve compound inequalities is to graph both inequalities on the same number line and find the overlap of the two shaded regions. So let's go ahead and draw this inequality in blue, and let's go ahead and draw this inequality in red, and let's see if we can find where the red and the blue overlap. Okay, x greater than or equal to 4. Well, greater than means shade to the right, and because it says or equal to, we put a bracket at 4, and then we shade to the right. Now to the 20. Very similar idea. Greater than to the right, and because it says or equal to, we use a bracket, and we shade to the right. Now, what part of our number line has both red and blue at the same time? Well, that would be 20 and up. So that means that x has to be greater than or equal to 20. And as an interval, that would be bracket 20, comma, infinity. Now this makes sense logically if you think about it. X has to be greater than or equal to 4, and by the way, x also has to be greater than or equal to 20. Which one of those is the more restrictive requirement? Well, it would be the 20. And certainly it's true that if x was bigger than or equal to 20, it would also be bigger than or equal to 4. And that gives reason for why this is the only one of those two conditions that we need to create our final answer to this problem. All right, so now we've found the domain. The only thing left to do now is to go back to where we were before we stopped and continue simplifying if possible. Now, the interesting thing about simplifying radicals is this. If there's any adding or subtracting underneath your radical, you can't split it up so that each of the little pieces gets its own radical. And because of this subtraction, we can't split this up. And because of this subtraction, we can't split this up. And for that reason, this is our final answer. This is how we're going to enter our solution into our learning software. This right here is g composed with g of x. And this right here is the domain of g composed with g of x.